Your Toyota transmission could already be wearing itself out every single day, and most owners have no idea they're the ones causing it. One factory dashboard setting quietly cooks the fluid. Another doubles internal valve body wear every single commute. And the worst part? Toyota actually enables some of these by default right out of the box. Today, we're exposing the transmission settings, modes, and habits that can turn a perfectly good, bulletproof Toyota into a $4,500 rebuild. Number 10, the lifetime fluid myth. Let's start at number 10, the lifetime fluid myth. Toyota proudly prints lifetime fluid in your owner's manual and seals the transmission casing with no dipstick. But the gearbox inside most modern Toyotas isn't some mystical wear-free machine. It's designed and built by Aisin, a company Toyota owns a massive stake in. If you look up Aisin's own engineering service bulletins, they don't say lifetime. They recommend a fluid exchange every 60,000 MI or 4 years. Even Toyota's own warranty supplement explicitly states that for severe service, which includes city stop-and-go driving, towing, or using a roof rack, the fluid must be changed at $60,000 a year. So why does the standard manual say lifetime? Because to a manufacturer, lifetime simply means the lifetime of the factory powertrain warranty, which is usually 5 years or $60,000. Once you clear that bumper, the manufacturer has zero financial interest in whether your transmission survives to $300,000. Whether you drive a RAV4 with the UB80 8-speed, a Camry with the UA80, a Tacoma with the AC60 6-speed, or newer Tundra with the direct shift 10AT, they all run on Toyota Genuine World Standard or WS fluid. Skip the service and the ultra-low viscosity WS fluid shears. Its anti-foaming additives oxidize, and suspended microscopic clutch debris turns the fluid into liquid sandpaper. That abrasive fluid begins wearing down the soft aluminum bores inside the valve body. A simple drain and fill with fresh Toyota WS fluid costs about $150 in parts and DIY time. Letting it go until the transmission slips will cost you $4,000 to $6,000 for a completely new Aisin unit. Do the fluid, ignore the dealer myth, and save thousands. Number 9, auto start-stop smart stop. Toyota calls it smart stop, and while it's designed to shut the engine off at red lights to cut emissions, it extracts a hidden tax on your drivetrain. Testing by organizations like the SAE shows fuel savings of roughly 5 to 12% in dense city traffic, but every time that engine dies and fires back up, components take a beating. Toyotas with Smart Stop require a heavy-duty cyclic resistance starter motor that costs $450 to $650 to replace, alongside a specialized enhanced flooded battery or EFB or AGM battery running $250 to $400. Those batteries typically last just 3 to 7 years under start-stop stress compared to 7 to 10 years in older non-ESS Toyotas. On the transmission side, Aisin had to engineer a complex workaround for this system. When the engine stops, the mechanical fluid pump stops spinning, which would normally cause line pressure to drop to zero and drop the transmission into neutral. To prevent a massive delay when you lift your foot off the brake, modern 8-speed Toyotas utilize an electric auxiliary oil pump mounted to the case. This electric pump cycles on to maintain just enough line pressure to keep the forward clutch packs primed. It's a clever band-aid, but it introduces an extra electric motor, wiring, and internal check valves that fail over time. If you want to protect your starter, battery, and auxiliary pump, your choices are pressing the A off button on the dashboard on every single key cycle, or plugging in a $50 aftermarket start-stop eliminator module behind the switch bank to permanently disable it. Number 8, the Eco Mode Trap. But while start-stop beats up your electrical components, the next drive setting wears out the transmission mechanics in a completely different way. Sliding down to number 8, the Eco Mode Trap. Eco Mode sounds like free money at the gas pump, but in city driving, it's a slow transmission killer. When you push that Eco button, the transmission control module TCM radically alters its shift maps. It forces the transmission to short shift, meaning it grabs the highest gear possible as early as 1/800 RPM and locks up the torque converter clutch almost immediately to eliminate fluid slippage and maximize efficiency. On a flat highway, that's exactly what you want. But in stop-and-go city traffic or moderate hills, Eco Mode forces the engine to lug. When you try to accelerate slightly without stomping the pedal, the TCM refuses to downshift to save fuel. Instead, it forces the torque converter clutch to partially slip to absorb the engine's vibrations while trying to move a heavy vehicle at low RPMs. This continuous micro-slipping generates intense localized heat. Automatic transmission fluid lives happiest below 200 F. For every 20 torque spike past that threshold, the life of your WS fluid is cut exactly in half. Eco mode in stop-and-go city traffic regularly sends internal fluid temps into the 220 to 230 degree Fahrenheit range. And because modern Toyotas lack a dedicated transmission temperature gauge on the dashboard, you have absolutely no idea it's happening. The smart move is simple. Turn eco mode off during city, driving, towing, or hilly terrain. Save it exclusively for flat, steady highway cruising where the transmission can lock into overdrive and stay there without hunting. Number 7, sport mode and valve body wear. Eco mode kills your transmission slowly, over 100,000 d'Ellermi. The next mode, however, accelerates wear under the guise of performance. That brings us to number 7, sport mode. Sport mode alters the TCM logic in the exact opposite direction of eco. It sharpens throttle response, commands higher line pressures, holds gears much longer into the RPM range, and initiates aggressive downshifts the moment you touch the brakes. While it makes a V6 Camry or a turbo Tacoma feel lively, running in sport mode during your everyday boring commute is an easy way to wear out an Asian valve body. Inside the transmission, shifts are executed by linear solenoids directing hydraulic fluid through narrow channels in an aluminum block called the valve body. Every single time the transmission changes gears or downshifts to assist with engine braking, a pulse of hydraulic pressure slams against these aluminum valves. Sport mode effectively doubles or triples the number of shift events during a normal drive. Over time, this constant fluid cycling causes the steel valves to wear out the softer aluminum bores they ride in. Once those bores lose their tight factory tolerances, hydraulic pressure begins to leak past the valves. This pressure drop causes sloppy shifts, gear flares where the engine revs up between gears, and eventual clutch pack destruction because there isn't enough pressure to hold the clutches together. Use sport mode when you're merging onto a dangerous highway or carving up a mountain road, but switch back to normal mode for the daily grind. Number 6, confusing adaptive learning. If you ignore this, the transmission's brain will try to compensate for the wear until it can't anymore, which drops us straight into number 6, adaptive learning memory. Modern Toyota. CTMs don't just follow a static computer program, they actively learn. Over the first few thousand miles of driving, the computer monitors exactly how many milliseconds it takes for a clutch pack to fill with fluid and how many bars of pressure are required for a smooth shift. It then permanently adjusts its internal software tables to compensate for the tiny manufacturing variations in your specific transmission solenoids and your unique driving style. The problem arises when a vehicle has multiple drivers with completely different driving styles, or when an owner is constantly switching back and forth between eco, normal, sport, and snow modes every few miles. This erratic input causes what engineers call adaptation degradation. The CTM continually tries to rewrite its operational tables to satisfy conflicting driving behaviors. The shift adaptations become confused, leading to delayed engagements, harsh downshifts, or irregular torque converter lockup timing. The fix is absolute common sense. Pick a primary driving mode, preferably normal, and let the transmission settle into its learned adaptation windows. Furthermore, if you ever buy a used Toyota, or if your vehicle begins shifting erratically after a battery replacement, you should know that the CTM's adaptive memory can be completely reset using a specialized scan tool. Resetting the tables forces the computer to clear its confused history and perform a clean slate relearn over the next 100 miles of driving. Number 5, the drive to reverse rush. But while the confused computer causes internal wear over thousands of miles, the next driver habit can snap heavy mechanical components in a fraction of a second. Sliding down to number 5, the drive to reverse rush. We've all done it in a crowded parking lot. You're backing out of a space or you're pulling forward into one and you throw the gear selector from drive to reverse or vice versa while the vehicle is still coasting at 2 or 3 miles per hour. It feels harmless, but underneath the vehicle, it triggers a catastrophic kinetic shockwave. When you shift gears while the wheels are moving in the opposite direction, the internal planetary gear sets are still spinning forward. Throwing it into reverse forces the transmission's internal clutch packs to violently halt that rotation and force it backward using pure mechanical friction. This sudden reversal sends a massive torque spike directly through the input shaft, the differential gears, the rubber engine mounts, and the CV axles. A genuine replacement CV axle runs $250 to $400, and torn motor mounts can easily cost $600 to replace. The fix is absolute common sense. Bring the vehicle to a complete dead stop with your foot firmly pressing the brake pedal, pause for 1 full second to let the hydraulics settle, and only then move the gear shifter. Number 4, coasting in neutral. That pushes us into number 4, coasting in neutral. This is a classic driving myth passed down from of carbureted engines. The logic used to be that if you're going down a long hill, slipping the transmission into neutral drops the engine to idle speed and saves fuel. On a modern fuel-injected Toyota, This is mathematically false due to a program called deceleration fuel cutoff, or DFCO. When you're coasting downhill and drive with your foot completely off the accelerator, the vehicle's momentum turns the wheels, which turns the drive shaft, which keeps the engine spinning mechanically. The engine computer recognizes this and completely shuts off the fuel injectors. You are burning literal zero fuel. If you shift that transmission into neutral while coasting, you mechanically decouple the engine from the wheels. To keep the engine from stalling out, the computer must instantly turn the fuel injectors back on and pump gasoline into the cylinders to maintain a steady 750 RPM idle. Not only are you burning more fuel in neutral, but you're also inducing unnecessary transmission wear. When you reach the bottom of the hill and pop the shifter back into drive at 50 mph, the TCM has to suddenly command a massive hydraulic pressure spike to slam the appropriate forward clutch packs together to match the engine speed to the vehicle speed. It's an unneeded high wear event that serves absolutely no purpose. Keep it in drive, let the computer cut the fuel, and protect your clutches. Number 3, the 4 low and part-time 4WD mistakes. But while coasting in neutral damages your transmission over time, our next setting can snap an expensive 4WD system on dry concrete in a single turn. Rolling into number 3, the 4 low and part-time 4WD mistakes. If you drive a part-time 4-wheel drive truck like a Tacoma, 4Runner, or Tundra, your center console features a rotary dial or lever for 2WD, 4 high, and 4 low. Many owners mix up how these systems operate compared to all-wheel drive crossovers like the RAV04 or Highlander. A RAV4 uses an automatic AWD system with a center coupling that allows the front and rear wheels to rotate at different speeds when cornering. A part-time 4WD truck, however, has no center differential inside the transfer case. When you switch into 4 high or 4 low, the front and rear drive shafts are locked together mechanically in a 50-50 power split. When a vehicle drives through a turn, the front tires naturally travel a wider arc than the rear tires, meaning they must spin faster. On dirt, mud, or snow, the tires can easily slip on the loose surface to accommodate the speed difference. But if you engage 4 high or 4 low on dry pavement, the tires cannot slip. The opposing rotational forces build up inside the drivetrain in a phenomenon known as driveline binding. You'll feel the truck hop, shudder, and resist turning. This binding puts thousands of pounds of destructive stress on the transfer case chain, the front differential gears, and the CV axles. Do it enough, and you will literally split the aluminum transfer case housing in half. Replacing a cracked Toyota transfer case runs $2,500 to $4,000. Use your part-time 4WD only when your tires are on a genuinely loose, slippery surface. If you're on dry asphalt or just rain-wet pavement, leave it in 2 high. Number 2, letting the transmission hunt in top gear. The next mechanical error involves using the wrong gear entirely when the vehicle is placed under a heavy load. That drops us to number 2, letting the transmission hunt in top gear. Modern 8-speed and 10-speed automatic transmissions are tightly engineered to upshift into ultra-deep overdrive gears as quickly as possible to meet stringent government fuel economy standards. When you are driving into a strong headwind, climbing a long highway grade, or carrying a heavy load of cargo, the transmission will constantly shift back and forth between its top overdrive gears. For example, dropping from 8th to 7th, then jumping back to 8th over and over again. This behavior is called gear hunting, and it is incredibly destructive to the torque, converter clutch, and the gear clutches. Every single time that transmission shifts under a load, the internal clutches must momentarily slip to smooth out the transition. This continuous shifting under stress generates a massive spike in fluid temperature. If you see your tachometer needle bouncing up and down every 15 seconds on the highway, you need to intervene manually. Knock the shift lever over into S or sequential mode and tap it down to lock out the top overdrive gears. Capping an 8-speed transmission to 6th gear or a 6-speed to 4th gear stops the gear hunting instantly. It keeps the engine in a higher, more stable RPM power band where it doesn't have to struggle, reduces torque converter slippage, and drops internal transmission temperatures by as much as 40 degrees. Number 1, towing in overdrive with no tow haul mode, which leads us directly to the number 1 most destructive transmission habit of all, towing in normal drive mode without using S mode or the tow haul setting. Towing a heavy boat, travel trailer, or utility dump trailer in standard drive mode destroys more automatic transmissions than every other item on this list combined. When you hook up a trailer, you are asking a transmission designed for a 4,000 LB vehicle to pull double or triple its normal weight. Vehicles like the Tundra and Sequoia come equipped with a physical tow haul button. Pressing it completely changes the transmission's behavior. It increases line pressure to clamp the clutch packs tighter, delays upshifts to keep the engine in its power band, and locks the torque converter clutch earlier to completely eliminate heat-generating fluid friction. The trap catches owners of vehicles like the Tacoma, 4Runner, RAV4, or Highlander, which often don't have a dedicated tow haul button on the dash. Owners mistakenly assume they can just hook up a trailer, drop the shifter into D, and drive off. Without a dedicated mode active, the computer will aggressively try to shift into high overdrive gears to save fuel, causing massive gear hunting and forcing the torque converter to slip under heavy load. Within 30 minutes of highway towing and standard drive, your transmission fluid temperatures can skyrocket past 250 degree F. At that temperature, automatic transmission fluid completely breaks down, losing its ability to lubricate internal bearings and causing the clutch friction material to literally bake and peel off the steel plates. The solution is non-negotiable. If your Toyota has a tow haul button, press it every single time you tow. If your vehicle does not have the button, you must manually move the shifter into S mode and select a lower gear cap to completely lock out the top overdrive gears. Forcing the vehicle to stay in a direct drive gear prevents the converter from slipping and saves your fluid. If you tow regularly, completely throw away the lifetime fluid manual and change your transmission fluid every 30,000 hours. Spending $150 on a routine fluid exchange will always beat paying $5,000 for a rebuilt ASIN transmission. If this video helps save your Toyota transmission, subscribe for more hidden automotive problems, mechanical breakdowns, and ownership secrets most dealerships will never tell you. Before you go, which of these driving modes do you use the most? Let me know in the comments below and click the video on screen right now for another hidden Toyota trick most owners still don't know about. See you there.